Welcome to today's lecture. We are going to continue from where we left over. Work, energy, and power. And let's define each of these concepts to understand what they really imply. Work, the symbol is W, capital letter W. And what is work? Work is the product of force and displacement in direction of force. The product of what? Displacement and force in direction of force. As simple as that. Distance move in the direction of force. If you can't put this definition in your head, you can say work is the distance moved in the direction of force. But when you say it's the product of force and displacement in the direction of force, that's work and that's work done. And what's the formula? The formula is given by work done, which is work, is equal to force times distance times cos theta. That's the angle at which the force was directed towards. That's this cos theta. Okay. If you were given an angle, maybe 70 degrees, 90 degrees, and so on and so forth, you are going to put that degree here, okay, as the theta cos theta. But if you were not given any angle, you are just going to do force times distance. You substitute. When you read your questions, you substitute force here, and you substitute distance into this place, okay, to get your work. You times that you get your work done, okay. So they can also ask you a question from this same work and work done, and they might ask you that so thing happened. The work done in the system is so cover the so distance. What was the force applied? What are you going to do if you are asked to do such? What you are going to do is just make F the subject of the formula, and you are now left with W over D. So you are going to have F is equal to W over D, and you solve to get force. If they ask you distance too, you make distance D the subject of the formula. It's all about rederiving from the parent or the base formula. You can always rederive formulas, okay, from formulas. Okay, so just derive, okay, make what you are looking for the subject of the formula and substitute, then solve and get your answer. As simple as that, Shikina. Physics is very, very easy. If you can know the basic formulas, you are good to go. Let's look at energy. What is energy? The ancient definition of energy. The capacity to do work or the ability to do work. Your ability to do work is energy. Your capacity, you are able, you can do work, that's your energy. Okay, your ability, your capacity to do work, that's energy. And there are various forms of energy such as kinetic energy, potential energy, heat energy, electrical energy, chemical energy, and nuclear energy, and so on and so forth. So the nuclear energy is the kind of energy induced from nuclear reactors, okay, from radioactivity and so on. Chemical energy from chemicals like chemical salts and electrolytes, okay. Then electrical energy are energies from, electric source, okay. Heat energy from heat source. Potential energy is the energy possessed by virtue of its position, okay, and energy stored in a substance when stationary. So this substance is stationary and that energy is stored in it, okay. That's potential energy. Then kinetic energy is an energy in a moving object or moving body. Now let's look at the concept of power. Power, which is capital letter P, can be defined as the rate of work done, okay. So the rate of work done is power, the power expended. That's the rate of work done, and is given by the relation P is equal to work done over time. P is equal to work done per time. Like I said before, if you want to use this formula to solve a question, for example, in your exam, all you need to do is to substitute, okay? Substitute into the formula, put work done as you were given, put time. But they can also switch it up, ask you a question. They ask you that, what's the time taking to apply so power to bring about a work done so. You are told to look for time. What do you have to do? You make T the subject of the formula. You make T the subject of the formula, you substitute, you solve and get your answer. If you are told to look for work done, power was provided, time was provided, look for work done, you make W the subject of the formula. As easy as that, Chikina, you get your answer. That's why you have to understand how to make subject of formula. It's very easy, okay? So if you want to make T, for example, here now, the subject of formula, you are going to have T is equal to W times P. That's making T the subject of formula. If you want to make W the subject of formula, you are now going to have W is equal to T over P. That's that for that. Conservation of energy. What is meant by conservation of energy? Conservation of energy means reusing energy, protecting energy to avoid wastage of energies, okay? Renewing energy instead of discarding them, instead of wasting energy, renewing them and protecting energy to avoid them wastage. You conserve them, you conserve energy. So energy cannot be created or destroyed, only transformed, okay? That is the first law of thermodynamics. Energy can never be created nor destroyed, but can be transformed from one form to another. So anybody that tells you that energy is destroyed, I will destroy your energy, I will destroy that energy, it never happens. You can't destroy energy and you can't create energy. Energy occurs naturally. So you can only transform them from one form to another. Maybe you have electrical energy and you need heat energy. All you have to do is to transform from electrical energy to heat energy. That's that for that. Transformation of energy. How do we transform energy? You transform energy in different ways, like I just explained earlier. Potential energy, you can transform potential energy to kinetic energy. Chemical energy can be transformed into electrical energy. That's it. You can transform chemical energy like in batteries, You transform chemical energy to electrical energy. Transforming potential energy to kinetic energy, for example, in a combustion chamber of an engine where you burn petrol or fuel to produce torque, to produce rotation, to produce oscillation of the wheels of the machine. So you use the energy stored in a substance to create a moving energy. As simple as that. And the final one we have here is solar energy to heat energy. That's solar accumulator. Okay, solar accumulator converts solar energy to heat energy. You see that energy it transfers from the sun. It stores that energy, and you can utilize it as heat. Or the energy from the sun, the solar energy, is usually very hot. So when it falls down to the earth, it is transformed towards heat energy, the ultraviolet ray of light. So let's look at the force distance curve. Force distance curve shows the relation between force and distance in a straight line graph. And the area, what's important to note is that the area under the curve is equal to work done. The area under the curve is known as what? Work done, or is equal to work done. Okay, so force distance curve is used to know the force required to move certain distance. Force distance curve, you want to know the force required to meet certain distance, okay, or to reach, or the force required to reach certain distance. That's how you use the force distance curve. So solving numerical problems, that's problems involving numbers from energy, power, and work. Okay, you use all this from, we just discussed it. Work done or work is equal to force times distance. That's this. You can either find any of these by making subject or formula depending on what you are given and the question you were asked, what you were asked to do. This one is kinetic energy. Okay, kinetic energy is equal to 1/2, which is half mv squared, where this is half, where m is what? Mass of the body, while v is equal to velocity of the body, v squared. You substitute and get your answer. Basic mathematics, chicken. So when you substitute here, you want to get your answer. How are you going to solve here? You are going to use this one to times everything here. So what you get from timesing mass and velocity square, first of all, you are going to do this velocity square first. Velocity times velocity. What you have here times what you have here. What you have here, this v, times the same thing. What you get, use it to times mass. Okay. Then you are going to times everything here. That's, we've gotten our total here now. We are going to use it to times this one here, and which is the same, over everything all over 2. And we are going to get our kinetic energy. And the formula for potential energy is PE. Potential energy is equal to mgh, where m is what? Is the mass, while g is what? Gravity, or acceleration due to gravity, while h is what? The height, normally represented in meters. Okay, if it's not represented in meters in the question, ensure you convert it to meter. If it's represented in kilometer, ensure to convert back to meter by timesing by 1000, okay, to get meter, converting from kilometer to meter. Remember, if you are converting down, okay, you are going to times. If you are converting to an upper nomination, you are going to what? Divide. So P, which is power, is equal to work done over time, or yes, work done over time taken. As easy as that, easy peasy. Like I said before, you can rederive formula from the same formula. Okay, from one formula, you can use it to rederive formula and get answer to your question, especially when you are asked a question that does not have its own formula. A question that does not have its own formula, they want you to make something the subject of the formula. Like when you are asked a question relating to this energy, power and work, and you are not told to find work done. Okay, maybe you are told to find what is the force or what is the distance. You are going to make subject of formula and solve. Like here now, power, you are told to find what is the time. You are meant to make what? Subject of formula. Like power here now, they also ask you what's the work done, and they give you power, they give you time. You make subject of formula, get your answer. That's it. They can also give you potential energy. For example, for this potential energy, they can give you potential energy, they can give you mass, they can give you acceleration due to gravity. They will ask you what is the height. All you need to do is to make subject of formula to get your answer. Now let's look at the force distance curve. This is the diagram of the force distance curve, and on this y-axis you have the what? The force. On the s-axis, which is horizontal here, you have the distance of separation. Remember what it states. It states that this area under the curve, this is the curve, okay? This is the force distance curve. This one, not this broken one too, not this broken line, okay? This one, this broken line is used to represent something. You see this distance here, this area here under the curve here, from here up to here. Here is the work done, okay? From here to here is the work done in this force distance curve. Remember, we use the force distance curve to measure the force required to attain certain distance. So this amount of force here, whatever value is here, was required to what? Have this work done, okay? To reach this distance. And everything, when you times both, you get work done. Energy and society, especially energy and our society, our current society. And we have to look at the source, first of all. The sources of energy, we have coal, we have crude oil, we have gas. 3 of them, these 3, coal, crude oil, gas, they are all classified under fossil fuel, okay? Fossil fuel, okay? While we also have sun, we have wind, we have water, and we have nuclear reactors or nuclear energy. All these are sources of energy, okay? So renewable energy include sun, wind, water, biomass, green energy. What's the meaning of renewable energy? Renewable energy means that the energy can be recycled, okay? It means that the energy can be what? Recycled. You can recycle the energy, okay? And you recycle it and you reuse it, like the sun. You can trap sun with solar accumulator and use the heat later, okay, to do something else. You can trap wind, okay? You can trap wind and use the wind to do windmill, okay? Windmill you find in power station. You can trap water and use water to wash. After washing with the water, you can recycle that water again, purify it and reuse it again. You continue reusing the water, it's renewable, and so on and so forth. But let's look at the contrast, which is what? Non-renewable energy. Okay, that's the opposite of renewable energy. What is the meaning of non-renewable energy? When you say non-renewable, it means that it cannot be recycled. Energy cannot be reused. As simple as that. You can't reuse it, you can't recycle it. That is what? The non-renewable energy. As you just finish using it, that's the end of the energy. It burns out. That's the end of the energy. And an example of these kinds of energy are, you have the fossil fuel. It's mainly the fossil fuel that falls under this category, okay? You have coal, you have crude oil, you have natural gas. You know how we use our coal. For example, you are using charcoal. Immediately you just burn it. Once you finish burning, you can't use any energy. The energy is exhausted. No energy to use again. You can't recycle it. If you use fuel in your vehicle or your generator at home, if fuel burn finish, energy never finish, can you recycle it again? So if you want to on your gen, you want to start your gen, you have to do what? Go back to the filling station and get another fuel. That's it. It's not renewable. You can't recycle it. You can't reuse it. So let's look at the uses of energy. We use it for transportation. We use it in industry to power machineries and to food industrial processes. We also use lighting. We use energy for lighting. It gives us light. And we use it for heating. Heat energy at home when we cook. It's energy we use to cook, heat energy. We also use energy for communication. We use electrical energy for communication, and so on and so forth. So let's look at the development of energy. What do we have to know about the development of energy? Energy drives technology. Yes, without energy utilization and quantization, there is not going to be what? Technological advancement. There's not going to be discovery. Everything run on earth requires energy. Everything. One of the major setbacks of Nigeria today is because Nigeria has persistent power failure. So if there was energy in Nigeria and we continue to enjoy steady power supply in every part of Nigeria, it's going to help with industrialization and technology, okay? So that's one of the major setbacks in Nigeria. So another one is industrial development. Like I said before, when there's energy, more companies will be developed, more companies will come, many people will come to establish because there's stable power supply. Power is life, energy is life, light is life. So in agriculture also, energy develops agriculture, especially the kinetic energy used to till soil, and also the energy required to process farm produce, okay, to make them more palatable, more cookable, more edible. So energy are required. We need energy to do all of these. Diversification of energy. The word diversification is very easy. It means exploring different sector. That's diversification. What is exploring different sector? It means try other sector, use other ones, use other option. For example, you have close-up toothpaste. Just imagine in Nigeria now, it's only close-up toothpaste that we have. We don't have other brands. It's going to put stress on close-up toothpaste. The demand is going to be very high and the supply will fall. Close-up will not be able to meet up and there's going to be what? Scarcity. But when you explore different sector or different companies making toothpaste, like Nigerians are doing now, exploring other companies using their product, it makes close-up available. You have close-up in mass, available for consumption, available for use, okay? Other than just using only close-up, focusing on only close-up. That's one of the problems Nigeria is facing economically, okay? We just focus on our only source of energy and income. We just focus on one sector as our only source of energy and income, which is what? Crude oil, the oil sector. We can't focus on agriculture. We can't focus on security. We can't focus on entertainment. There are other sectors that we can also work on to diversify so that we can generate more revenue and have enough revenue to run the nation, okay? So that's what it means by diversification. So diversify energy to ensure enough supply, okay? When you diversify, you explore various sources of energy, you are going to have more than enough to supply. When, let's say food, for example, when you are at home, you decide to buy only rice, okay? Only rice, that's what you bought and kept at home. Before you know, your rice will finish. But if you buy rice, you buy beans, you buy spaghetti, you buy yam, you buy different food and keep it at home, you are going to have different options. Because when you buy only that rice and leave it at home, there are some days that you will not feel like eating that rice, okay? What are you going to eat? Nothing, because you have no other food. But when you are tired of eating rice and you have other food at home, you are going to have other options to pick from, okay? You can easily just revert to another one or resort to another one. Very easy, very easy, because of diversification. You explore different sectors, okay, to ensure availability. So when there are different food, there is availability of food, different options for food, different option for carbohydrates. Just imagine that it's only rice that is giving carbohydrates. We don't have other sector, or everybody just decide to face only rice. Say now only rice, now all the carbohydrate day. We don't want to buy other ones, only rice. There is going to be scarcity in the availability of rice because of that, because the demand is going to be high, supply falls. Basic economics. And diversification helps solve this, okay? So when people begin to diversify, begin to explore different sources of carbohydrates like spaghetti, like yam, you are going to see that you are going to have more carbohydrate food available for consumption, even the one that we are not capable of consuming in a long time. So let's look at environmental impact. What is the environmental impact of energy? Global warming. What is global warming? You know what global warming is? Global warming is when the ice glaciers, okay, you know, there are countries that have ice hills, okay, ice heap in their country. So those countries, when the heat is high on the earth due to energy combustion, when we use energy, it in turn releases heat. So those heat release can lead to the melting of those ice glacier, and you start experiencing global warming, which is what? Flooding. Global warming is flooding, okay? When everywhere is hot, ice glacier melt, and the effect of global warming, you start seeing flooding everywhere. Rivers and water bodies, seas begin to overflow. So that's that for that. Global warming, one of the effects. Another effect is greenhouse effect. Greenhouse effect is the effect induced by carbon dioxide, okay? You know that the end byproduct of combusting these energies, especially fossil fuel, is carbon dioxide, okay? So this carbon dioxide, when it gets to the atmosphere, it causes the release of heat that falls back to the earth, which is known as the green effect, okay? The earth becomes so hot because of this accumulation of carbon dioxide, okay? So another environmental impact is oil spillage. You know how oil spillage occur, okay? When the pipings of the petroleum sector, the petroleum line, okay, gets ruptured. And when it ruptures, it enters the water body, and you get oil spillage in our farms. Not only water body, our farmlands too. It affects crops growth and so on and so forth. It affects aquatic life, okay? Many aquatic lives are destroyed. So there are ways to eliminate this oil spillage. The easiest way to eliminate this oil spillage is there are oil-eating bacteria, okay? You put oil-eating bacteria into the water body or the sea, and they eat up the oil with time, and the sea is free from oil. So the greenhouse effect, how do we reverse this greenhouse effect? We reverse the greenhouse effect by afforestation. Planting more trees. You know, plants, especially flowering plants, uses carbon dioxide to photosynthesize. They need carbon dioxide to produce their own food. So the more trees you plant, the more carbon dioxide available. And that's why we also need to diversify. Why diversification is also good. We use other sources of fuel that does not produce this carbon dioxide. This is another method of controlling this greenhouse effect. Use other types of fuel that does not produce carbon dioxide as waste. Then another method of clearing oil spillage or preventing oil spillage is surveying the oil pipelines, ensure steady or periodic maintenance to check for leaks or weakness, so that any hazardous situation that can lead to disaster can be addressed. So we also have pollution, you know, especially air pollution. From energy use, air pollution, you also have water pollution, you also have sound pollution, sound from machineries, air pollution, air pollution, the gases, like carbon dioxide, carbon monoxide, different gas, sulfur dioxide released into the atmosphere, a lot. And you also have water pollution, especially when chemicals are released into the water bodies, or the companies or industry uses water from the sea to cool their machineries, and they send those hot water back to the sea, and which is very detrimental to aquatic life. So that's the impact on the environment. Let's look at the energy crisis. What are we facing currently as regards energy? It's shortage. And what is causing the shortage? Because we rely so much on one particular source of energy. Okay, that's why the need for diversification is inevitable. So rising costs. So when there's shortage, the price increases. High demand leads to what? Increase in price. Okay, so let's look at conversion. How do we convert energy? Like we discussed earlier, chemical energy to electrical energy. That's in batteries, like the one you do in batteries, from chemical energy to direct current, DC. Then solar energy to electrical energy, done by what? Solar panels. So what are the devices that generate energy, or devices that converts energy? We use generators, which converts what? Potential energy to kinetic energy, okay, then to electrical energy. From potential energy, the one in the fuel, it converts it to kinetic energy, okay. When it converts it to kinetic energy, it forms heat energy, then forms what? Light energy, okay. Also turbine, okay. This turbine is used in power stations, okay, where electricity is generated from water, okay. Use turbine to create that wave in water that forms electric current, or that generates electric current. The another one is solar panel device. Solar panels can convert solar energy to electrical energy. Then we have nuclear reactors, okay. Nuclear reactors can produce electricity and heat energy, and so on and so forth. Dams and energy production. What is the location of dams? Okay, they are usually located in rivers with high flow and valleys. I hope you remember the famous Kainji Dam in Nigeria, okay, our power station where electricity is generated. So how is energy produced from a dam, or how is electrical energy produced from a dam? The electrical energy formed from a dam or induced from a dam is called hydroelectricity or hydroelectric power, okay, and it is formed via turbine driven by water flow. So the water flow, the wave from the water moves the turbine. So as the turbine moves, there is an alternator in the turbine that converts that kinetic energy to electrical energy, and over time it amounts to electricity, and they use various step-up transformers to raise the voltage up. So nuclear energy. What do we understand by the word nuclear energy? Nuclear energy is produced by what? fission. Okay, when you say fission, it means splitting of heavy nucleus. Okay, or it can also be formed from fusion, which is combining two light nucleus, okay, to form a heavier nucleus. So the essence of this one, fission, is to form lighter nuclei, okay, to break down a heavy nuclei to form lighter nuclei. While the essence of this one, fusion, is to form a heavier nucleus, okay, to form a heavier nucleus. And nuclear energy provides large energy, okay, large amount of energy, but has radioactive risk, okay. Radioactive risk is even more detrimental than the ones we have in our fossil fuel, okay, energy from fossil, okay. So that's why nuclear energy is not commonly used in Nigeria, because I think Nigeria doesn't have what it takes to maintain a nuclear plant at this time, because if you do any play for there, it's going to cause a disastrous catastrophe. Solar energy. Solar energy. Let's understand what solar energy means, okay. Photoelectric effect. From sun, which is from light, towards electricity. That's photoelectric effect. And what is the meaning of photoelectric effect? It means the emission of electrons when light strike on a material. So when light strike on the solar panel, it converts it undergoes certain processes, electrical processes, and electrons are emitted, okay? Electrons are emitted, and that's what? Electricity. So it's given by the relation work function. This is work function, the symbol for work function. Work function, which is the what? The minimum energy required to release electrons. So the minimum solar energy required to release that electron to start producing that current is work function, okay? And work function is equal to Planck constant. So Planck constant and work function are always equal. They are always the same. That's what this means. So if you are given work function and you are told to look for Planck constant is the same as work function. If you are given work function and you are given Planck constant and you are told to look for work function, work function and Planck constant are the same, okay? Because it says here in the formula that work function is equal to what? Planck constant, which is hf. So this is the Planck constant, okay, h. And the Planck constant is given as 6.63 times 10 to the power minus 34 joule seconds, okay? Let's look at solar collector. Solar collector or solar accumulator is a device that absorbs sunlight to produce heat, okay? You store, because sunlight is a renewable energy, you use solar collector or solar accumulator to absorb the sunlight, absorb the power, and store as heat. So when heat is required, when heat is needed, you use it. You can use it to cook and so on and so forth. Solar panel is also known as photovoltaic cell, okay, which converts sunlight directly to what? Electricity. Simple machines. Simple machines. What is a machine, or what is a simple machine rather? Machine refers to any device that makes work easier by multiplying force or changing direction. Machine makes work easier. It does this either by multiplying the force. Maybe you put 5 Newton, you apply 5 Newton to the machine. This machine will multiply that your 5 Newton by 20 and give 100 Newtons. So that's what machine does. So that 100 Newton that it gives, just imagine what your 5 Newton would have done. And now you are having 100 Newton. You are going to achieve a lot. The machine is going to help you achieve a lot. That's why it makes work easier. So the machine also operates by changing direction, okay? Changing the direction of force to where is needed. So these are the two ways in which machine makes work easier. So let's look at the types of machine. Under the types of machine, we have lever, we have pulley, we have wheel and axle, we have inclined plane, we have wedge, we have screw. The screw, this screw is normally called screw jack, okay? But there are other types of machine that wasn't listed here. So you do yourself a favor, go and take that as your assignment. Find other types of machine. I will give you the list that you should find for your assignment. Jamb always set questions from this, okay? So look for it. Go to your AI and search, or look for it in your textbook. Look it up in your textbook, okay? Search for, ensure you learn all the velocity ratio of the types of machine. They have velocity ratio each. They have their velocity ratio. For inclined plane now, for example, is 1 over sine theta, okay? Inclined plane, for example, is 1 over sine theta. The rest have velocity ratio. Also know their velocity ratio, but it's not all of them that have velocity ratio. There are some that do not have velocity ratio, okay? Like wedge does not have velocity ratio. Screw jack does not have velocity ratio. There are other machines that are missing here, about 2, which is hydraulic press and gear. Hydraulic press and gear, okay? You also need to figure that out. The formula or the velocity ratio of gear is driven wheel over driving wheel. Driven wheel over driving wheel. So if you are given a question of that, use driven wheel over driving wheel. The driven wheel is the wheel moved by the driving wheel. That's the driving wheel is the source of the energy, the kinetic energy that is driving the gear system or that is rolling the gear system. So that one is driving wheel, is the one driving it. Then the driven wheel is the one that is rolling, the one that receives the resonance from the driving wheel, the one that gets induced kinetic energy as a result of frictional contact between the driving wheel and it. That one is the driven wheel. It's being driven by the driving wheel. Okay, so machine can also be defined as a device that uses force in form of effort, small force in form of effort, small force. So it uses small force in form of effort to what? To overcome big load. Okay, it uses small force in form of what? Effort to overcome what? Big load. That's machine for you. And mechanical advantage. The mechanical advantage is given by load over effort. That is mechanical advantage. So the load overcame by effort or per the effort is mechanical advantage. The load overcame per the effort or over the effort used is known as mechanical advantage. Let's look at velocity ratio. Velocity ratio is the distance moved by effort per the distance moved by load. So the distance moved by effort over the distance moved by load. Get all this formula into your brain. Get all this formula into your brain. Because you can as well, like I said before, they can ask you to find anything here. You can have this ME, mechanical advantage equal to load over effort. They can give you a question and ask you to find the effort. So what are you going to do? You make effort the subject of the formula and you solve for what's the effort. They can ask you to look for the load. What is the load? You don't have formula for load. So you are going to use this mechanical advantage formula to make load the subject of the formula and you get your answer as easy as ABC. Physics is very easy. So velocity ratio, the same thing. You can be given velocity ratio and you can be told that find the distance moved by effort. Or you can be told to find the distance moved by load. And you are giving distance moved by effort and you are giving velocity ratio and so on and so forth. So efficiency of the machine, this symbol is also the symbol for viscosity. Okay, this symbol you have here, but here it represents efficiency. Okay, efficiency of the machine is given by mechanical advantage per the velocity ratio times 100 over 1. Mechanical advantage over velocity ratio times 100 over 1. So that is how to solve the efficiency. As easy as that, easy peasy. So you can be given mechanical advantage and you can be given efficiency. And you can be told by Jamb to find the velocity ratio. What do you have to do? You have to just make this velocity ratio the subject of the formula. So making V arrow the subject of the formula, basic mathematics, you are now going to have V arrow, you bring V arrow to this side, is equal to what? ME times this thing, efficiency, times 100 over 1. That's how you are going to get the velocity ratio. Very easy, easy peasy. So let's look at the application of machine. Application of machine. Machine is used to, we use machine to do almost everything on earth. Even your phone that you are using to make call is a machine. It's a type of lever. Okay, it's a type of lever. It's a machine. Everything we do on earth now, we use machine. We use machine to achieve them. So you have to know. Even like I said, your phone is a machine. Your pen you use in writing is a machine. Your spoon you use in eating is a machine. Your broom is a machine. So they are all machines. Okay. Anything you hold, anything you take advantage of is a machine. Anything you use as a leverage, as an advantage to do anything is a machine. Even your slippers, your palm slippers, your shoe is a machine. Your shoe is a what? It's a machine. The one you use in walking. Okay, it can be a machine. They are part of levers. So let's look at the application. It says lifting load, cutting, like your knife in the kitchen is a lever. It's a type of lever. Fastening is a type of lever. Transport is a machine. We use machine to transport. Okay, and so on and so forth. So like I said, I gave you an assignment to find the velocity ratio of each of the types of machine. First of all, look for all the types of machine. Search on AI or your textbook. Go to simple machine on your textbook. Look for the types of machine. Search for, know all the types of machine. I said not all of them have velocity ratio, but some, very few have velocity ratio. But make sure you know their velocity ratios, okay? Because Jamb always repeats questions for velocity ratio of each types of machine. And another thing, like I said before, I gave you two machines that were not included here. They are hydraulic press and gear. Okay, they were not included here. And this lever, okay, this lever have about 4 classes of lever. You have the first class lever, you have the second class lever, you have the third class lever, you have the fourth class lever. You have to know the differences between these four levers, the 4 types of levers. Ensure you learn it. I'll give you an example. First class lever is a kind of lever where you have the fulcrum. It all depends on where the fulcrum is located. That's how you differentiate the types of lever, where the fulcrum is located. Okay, the first class lever, you have the fulcrum in between the effort and the load. In second class lever, you have the load in between the effort and the fulcrum. So you can see the difference. So the fulcrum shifts. So know where the position of the fulcrum is in each of the levers. So you can define them to know their example. For example, the first class lever is scissors. You have the effort in that flange. Okay, that flange you have the efforts there. Okay, the pivot or the fulcrum is in the middle, while the load is a top or the distal part of the scissors. Why second class lever? Second class lever is like wheelbarrow or spoon you use in eating, where you have the fulcrum as the terminal end. So and so on and so forth. Your phone you use in making call is also a first class lever. You have the effort here, you have the fulcrum in between, and you have the what? The load here. Okay, depending on the end, who is speaking and who is listening. That's what is going to determine the type of lever that your phone is. Okay, now that we have understood simple machine, energy, work, and power, let us take some exercises, some Jamb repeated question to further test the knowledge we've acquired so far. Jamb must repeat questions. Question 39. A block just begins to slide when a horizontal force of 25 Newton is applied. If the normal reaction is 50 Newton, what is the coefficient of limiting friction? A 0.25, B 0.50, C 0.75, D 1.00. Drop the answer in the comment section. Question 40. A force of 10 Newton moves a body through a distance of 5 meters in the direction of the force. How much work is done? A. 10 joules, B. 25 joules, C. 50 joules, D. 100 joules. Drop the answer in the comment section. Question 41. A machine does 600 joules of work in 20 seconds. What is the power output? A. 15, B. 20, C. 25, D. 30. All options represented in watts. What's the answer? Drop the answer in the comment section. Question 42. A ball of mass 2 kilograms is dropped from a height of 5 meters. Neglecting air resistance, what is its kinetic energy just before hitting the ground? Take gravity, that's the acceleration due to gravity, equal to 10 meters per second square. A. 10, B. 20, C. 50, D. 100. All options represented in joules. Drop the answer in the comment section. Question 43. Which of the following is a renewable source of energy? A. Coal, B. Crude oil, C. Natural gas, D. Wind. Drop the answer in the comment section. Question 44. A lever is used to lift a load of 200 Newton with an effort of 50 Newton. What is the mechanical advantage of the lever? A. 2, B. 3, C. 4, D. 5. Drop the answer in the comment section. Question 45. A machine has a velocity ratio of 5 and a mechanical advantage of 4. What is the efficiency? A. 40%, B. 60%, C. 80%, D. 100%. Drop the answer in the comment section. Also ensure to look up the types of pulley. I think pulley system has about 3 types. Okay, pulley system has about 3 types. Ensure you know the types of pulleys. Okay, we have single pulley system, we have double pulley system, we have triple pulley system. So understand the mechanism of action. The single pulley system is the one we normally use those days in the well, where you just turn one wheel like this as you the string continues to coil on the frame of the wheel. You use it to serve as a machine, okay, from effort to load and so on. It pulls the load of water from the well and elevates it up to the height that you are at. Then you can take the bucket or the fetcher, then pour in the bucket, and you release it back counterclockwise back until it gets to the depth of the well where water is found. All right.